Hello everyone, it's October 1st. Alright, let's do this. Remove colored pieces if both neighbors are the same color. There are n pieces arranged in a line, and each piece is colored either A or B. You are given a string colors. Well, for length n, where colors I is the color of the ith piece. Alice and Bob are playing a game where they take alternating turns removing pieces from the line. In this game, Alice moves first. Alice is only allowed to remove a piece colored A if both its neighbors are also colored A. She is not allowed to remove the piece that are colored B. Bob is only allowed to remove piece B if both its neighbors are also colored B. He is not allowed to remove pieces that are colored A. Alice and Bob cannot remove pieces from the edges of the line, and of course, because you don't have neighbors on both sides. If a player cannot make a move on their turn, the player loses and the other player wins. Assume they play optimal, turn true if Alice wins or false if Bob wins. So in this case, Alice move, right, to become this, and Bob cannot make a move. Thus Alice wins. Alice cannot move, so Alice loses. And Alice make this move, Bob make whatever move, Alice cannot move. Okay, interesting. All right, let's try this example. I mean, this is like deterministic for this one. But anyway, it says Alice can only remove a piece colored A if both its neighbors are also colored A. So which means we need to find stretches of A of at least in 3. Right? Stretches of A of at least 3. I mean, if you think about it, if you go through the whole thing, okay, and you give, let's say we have a stretch. This is 0, 1, 2, 3, 4, 5, 6, right? So for Alice, all she can do is find a stretch of A, right? We have a stretch of A. And then within a stretch, if we note the front and end, and these A's are all free to move, right? It doesn't really matter. You can move any one of these, just cannot move at the end. So that's the total number of moves Alice can do, and Bob cannot do anything to it. And for Bob, it's the same thing, right? So at the end, all we need to do is to find the stretch of A, to find how many moves Alice can make, and how many moves Bob can make. In this case, Alice can make 1 move, Bob can make 0 move, so Alice wins, right? In this case, Alice makes 0 move, Bob makes 0 move. Alice loses because Alice goes first. So in this case, Alice make 1 move. Bob can make, dear Lord, 1, 2, 3, 4, 5. Bob can make 5 moves. So Alice wins when the number of moves, because Alice can make a move, Bob makes a move, and Alice make a move, and Bob cannot make a move. So if Alice, the move, is larger than Bob's move, then Alice wins. Okay? Otherwise, if Alice is smaller or equal to Bob, so like if both has 1, like say if we're A and B, then Bob wins. Right? We can take a so I think it's going to be false, right? If we do A and B, that should be false because Alice has no move. Yeah. So I think there's no DP or whatever, right? You just go through the whole thing, count how many moves Alice can do, because it doesn't really matter. You remove, it doesn't change the shape of the colors. It does not change. You can change because it has to be flanked by 2 A's. So that's the only thing you can remove is the middle. Like we won't have a situation where, let's say we have, like this, right? You can say, can we remove this B so that Alice has more move? You can't, because this B right? So like the only case when people can move is if you have multiple of a's, and when you move, and at the end, you are always remaining as two a's or two b's, right? And that you can no longer move. So whichever is on the outside of those, it can, yeah. So basically, what it says is you can move however you want, but the move will not connect the things on either side. It's not possible, which means it's deterministic. That's my understanding. So I'm going to try this. Okay. That is my understanding. I think it is deterministic. No, that's the wrong one. I think it's deterministic. Basically, all we need to find is just, the stretch, right? So what we need to do is count the stretch of A's and count the stretch of B's, right? If it's larger, yeah, so we're going to say A moves equal to 0, right? And B moves equal to 0. And for, and also int count A, int count B, okay? For int I equal to 0, I smaller than colors dot length, I plus plus. I need to make sure that it's if I is larger than, if I is equal to 0, or colors dot char at I is equal to colors dot char at I minus 1, then that is not good. Count shall equal to new int 0 0. What? Oh, int. My bad. Okay. Then we can do, I think it's 65. Right? 65. So we can say count colors dot char at I minus 65 plus plus. Right? Let's just, we count how many same. And then once we have an else, which means the current is not equal to the previous, okay? The current is not equal to the previous, then what we need to do is, moves. I think this one will be easier if we go moves also, new int. Okay, all right, else. Then we can say, we update the moves. We say moves colors dot char at I minus 1 minus 65, right? Plus equal to mass dot maximum of 0 and count colors dot char at I minus 1 minus 65 minus 2. That's the total number we can add, right? So moves will be this. So we update the moves, and then what? After we update the moves, I need to reset the count. Okay, so count colors or reset it to 0. So we say colors char at I minus 1 minus 65. We reset this to 0. Okay, so no more count because we finish it. And then when I get out, we'll always do here, which means we can say if it's larger than 0 and this is not equal to the previous one, okay, so we have this mismatch. When we have mismatch, we count how many moves we have, and then what's the problem here? Multiple occurrence. Screw this. We count how many we have previously. No, we do the moves, and after we reset it to 0, right? And then we add a current one. And then when we have this, we reset this to 0, and then we go all the way down. And then we shall return moves. So return true if Alice wins. So 0 shall be larger than moves 1. I don't know. That's kind of my understanding of how this problem is going to be. Can use this. So I can do this. All right. Let's try another one. Okay. Uh-oh. That's not right. Expected all false. I got some true. Hold up. Are these all right? These are not right either. Last one is false. True, false, false. True, false, false. Last one is false. That's interesting. Did I count it wrong? That's all right. Let's take a look. We have a string. Colors. A, B, B, B. Okay. Winner of game. Colors. And I'll use debugger becomes just a habit. I absolutely like how this one is happening, right? So colors 1, 2, 3, 1, 2, 3. Oh, I didn't update. Shoot. So when it's done, I need to go the last one, right? I need to handle this last one. I'm gonna do one more on the moves. Now it's not I. This is gonna be colors.length, right? And then it's gonna be count colors.length, right? Because when you go to the last one, you have to update the last one. Okay, so if that stop and rerun, that will be false. Okay, we'll just add this one more line. Then this one shall be working. Okay, let's reverse to get all that. Okay, can I give it a shot? Yeah, I think we can give it a shot. Let me make it more explicit. So we can say index current, index pre, okay? Then index current shall equal to this. Okay. And then, oh, shoot, that's right. And then index pre shall equal to this. Then we can do, this is index. Now this is fine. Oh, hold on, we don't even have index current. Is this index? Oh, we do have index current. That's fine. So just basically index pre, all right, plus equal to, let's do index pre, all right, and then this is count is also index pre, right, and then this is index current, right, and then we say index current. Now index pre, in this case, will equal to this, right, and then we do the same, index pre and index pre. Okay, more explicit. Okay, let's try this. Huh? Why so slow though? I didn't think I use any, I don't know, do you think? It's just slow. Okay, but anyway, we got this one, but for whatever reason, it's super duper slow. (2038). There's no trick here because it is impossible to remove some colors and connect the colors on the left and right together. Thus, all we need to do is to find out the total number of moves Alice and Bob can make. Alice wins if she has more moves than Bob. Alright, so I'm gonna fancy some methods to, get. Maybe we just remove one more check. I mean, that can be, right? That maybe make it faster. What do you think? Remove this check. Remove this check. Yeah, we can. Let's say we do, well, initialization. I can say I just need, moves will stay the same. It's the count. We just say count colors.char at 0, right, minus 65, or plus equal 1. That's it. And then I can start from 1. Then I can remove this check. All right. So maybe that can make it faster. Because the rest is, the same. Okay, let's try to see if this one make it any faster. Does one make it faster? Nope. It's just 1 millisecond faster, but that's fine. All right, let's check the solution. Maybe there's a, better way of doing this. Okay, I'm gonna put it. We can do it. Like, I think Python, if I do it Python, I think I can do it in one line. Maybe. I think it's gonna be group by, right, colors for key and G in this what we need is what do we need? I need the count, right? I need a count. I can say count is a counter. Wait, hold on, because I already have the count. So I can just do the moves, right? Moves is going to be a counter. And then here I can say moves k plus equal to line list g minus 2 and maximum this and 0, right? Now we return moves a larger than moves b. Does it work? Yeah. Right. All right, let's take a look at solution. Count. Oh, hold on. Colors.chart is equal to this. And colors is equal to this. Then Alice plus plus, Bob plus plus. Oh, it's a direct count. Direct count. So you basically just, so I think the solution is, which basically counts the moves from Alice and Bob directly. So it avoids setting up, yeah, I can see why. Okay, so we can say int Alice, right, int Bob, and then yeah, you can go from 1 and you don't go to the last one, right? And then you say if colors.chart I minus 1 is equal to colors.chart I, and yeah, colors.chart I equal to colors.chart I plus 1, right? If they're all equal, then you say if colors.chart I is equal to A, then Alice plus plus, otherwise Bob plus plus. Oh, it's all right. Just slightly faster. Just slightly faster. Okay, so that's that. Let's put that one here as well. Okay, so yeah, we're done with this. So today I ordered, okay? I ordered 30-day premium. But it's still processing. I ordered in the morning, but it's still processing. I want to do more JavaScript. All right, so let's try this one more time. Design cancelable function. Okay, let's see if we can still figure it out. So, oh, it's gonna have to yield. Damn, I forgot. How do we do yield? Accepts a generator and then returns an array of 2 values, cancel function and a promise. You may assume the generator function will only yield promises. It is your function's responsibility to pass the values resolved by the promise back to the generator. If the promise rejects, a function should throw that error back to the generator. If the cancel callback is called before the generator is done, your function should throw an error back to the generator. That error should be string cancelled. If the error was caught, the returned promise should resolve with the next value that was yielded and return. Oh, I have to go with generator. I forgot. How do I pass the value back to generator? JavaScript generator. Next. To send a value, so use next to send. Equal to yield, next one. The first value sent through next is lost. Because next, this one yields something. And it doesn't yield. And then you pass it to one. So this one is lost. Because the first time you call next, yeah, because you call yield, value is it's paused right here, right? And then when you call next, wait, hold on. The first call does not log in because generator was not yielding anything initially. Wait, hold on, I don't understand this. Why? The first call does not log anything because the generator was not yielding anything initially. Undefined. Wait, hold a second. First, next. Why? When you call next, it just calls the generator function from start to the first yield and then returns it just rules, right? It just rules. The following calls will make yield operator return the value. I guess just don't try to understand. This is how, I just say this is how it's done. Okay, so what do we want to do? I think the thing we need to know that we need to return, right? So we can actually go from here. We need to return, okay? We return an array of two values, a cancel function and a promise, right? This is what we need to return. So in the cancel function need to be a function, right? Const cancel. It's going to be a function, but function of what? I don't know at the moment, right? The cancel is going to be a cancel function. When it calls, something happens, right? Something happens. What happens? And then we need to return a promise, so I need a promise as well, right? So we need a promise. That must be a new promise, okay? We say resolve, reject, and something, right? So what we want is the generator. You may assume that it will only yield promise. It is your functions want to pass the values resolved by the promise back to the generator. So we probably need to call generator next. Okay, first next. But this will yield something. So let val equals this. Okay. And then what? The cancel function. If I call the cancel function, when the cancel function is called, if the cancel callback is called, so the cancel function can return, let's say, a promise as well, right? Then each time a cancel promise, right? So each time, basically, the two can race. Hold on. So you're telling me we can have a cancel promise. A cancel promise. So the cancel function, so what does the cancel function do? So when you call the cancel, can I just do that? A new promise? This should be inside of this. Can I just say, when you call cancel, then cancel.promise. Ugh. I want to call cancel function. When it's called, the cancel promise gets rejected. How do I do that? If the cancel function call, then the cancel promise gets rejected. Yeah, how do I accomplish that? Cancel promise is a new promise. We have resolve and then reject, right? In this case, we can just say reject. Yeah, I want cancel to call. When cancel is called, I want the promise to be rejected. I don't know how to implement this. Yeah, cancel is a function. Then when you call, you'll reject a promise. You'll reject the cancel promise. How do you reject a promise that you already set up? I feel like I'm almost there, right? You have a promise, and the promise would take two values, right? And then it either resolve something or reject something, right? In a certain situation, it will resolve. In another situation, it will reject. So this one does not resolve. So in a certain situation, it will reject, right? It will reject. So what is that situation? So let's say this is the same, right? And then in this case, it's just a resolve. It's just reject. Okay, or reject. So under some situation, this one will reject. And what is this situation? When cancel is called. And how do you know that cancel is called? Let's say cancel called false. Okay, and this would just say cancel called equals true. Okay, right? And then we say if cancel called, then we'll reject it with cancelled. Okay, so we have a cancel promise, so we have a flag, and then we have this, then we have a value, then we now have a promise, right? Then we just say const val, no, val shall equal to maybe I can do async. Await, go ahead and try. Say try val equal to await promise dot raise generator dot next. Does that make sense? Nope. I think it should be val, because this is already a promise. And then cancel promise. Okay. So this is get a value, right? And when we get a value, we can say val equal to generator on next val. Feels stupid. Right, because I call this is the first value, and this is a promise. So I will erase this promise with cancel promise. And whoever gets out first, let's say value gets out first, then I get a value. This value is a value. Okay, this is a value. And then I put this one in. Wait, hold a second. Aren't you supposed to... Is it supposed to be a loop? Alright, it should be a loop. So a generator will yield two things, right? The value and done. Right, value and done. But you say this generator will yield a promise. So the value is a promise, right? The value is a promise. So what I shall do here is maybe it should be a while val, and let's call it res, while res dot done, right? Well, it's not done. Then we'll try dot res dot value, right? So this is res dot value. It's a promise, so we erase this and we get to a val, right? And then this will become a res, and I can do a const here, right? Const val will equal to this, and I put this in and I get a new res out. So and then we say catch error, then we'll say generator dot throw, we put error back in. Does this one work? Nope. Oh, it didn't do resolve or reject. Oh, I can, you don't need resolve or reject, right? Wait, hold on. We need resolve and reject. Promise. Hold on. I just need to return a promise, right? What if I just do, I call an async function, okay? Async, this is async function, right? This is an async function. And then I call it. This gives me a promise. Okay, const, just call it function, right? This is async function, and now I return, okay, so promise function, right? And then we return a promise, which is promise function fun. Let's call it fun. Promise fun. I call it. When I call it, right, it's async. It returns a promise. Doesn't work. Does not work. So it's wrong because the promise dot then pass the values resolved by the promise back to the generator. cancel callback is called before the generator is done. The function should throw an arrow back to generator. There should be, the error was caught. The return promise should resolve with the next value that was yielded or returned. Otherwise, the promise should reject. So, oh, I think maybe we need to return it at the end. I don't know. I think I probably need to return the value, right? So maybe I need to get let val. So val get this. And the next one comes in. Yeah, rest is not done. Now we have the current value. Next one, rest is done. What if rest is done? We still need to go through this. We still need to go through the promise. The last value, right? The last value. You push next in, then the generator produces the next value is res. And if the rest done is true, then you don't even go inside. So maybe this shall be while true. Okay. This is while true. And then you do this. Okay, then you check if rest are done, then you break. Otherwise, you keep going. And then we need to return val. Okay, is this one right? Eesh, rejected. What? I have no idea. Do we have at least something? Nope, we didn't have anything. Huh? It's already true. What the hell? Yeah, because it's only one. It's understandable. Because you only do it once, right? Your yield. Rest. How about rest of value? What's the rest of value? It's 42. Shouldn't we break it out? Why this one is not called? Because this is not a generator. This is not a promise. But you said generator function will only yield promises. Now this one's yielding promises. I'm not sure what this one. Yeah, I think this throw this. But why would you throw? I don't understand. Promise or race. Hold on. Did I understand this one right? Promise race. Oh, I think I know why. Syntax error. Dude, it's supposed to be this. Ah, okay. Syntax error. Oh yeah, race, you need to pass a list. You pass an array of things. Okay, let's try all the others. They're all right. Ugh. Okay, not all of them. One of them should be resolved. Oh. Oh. That was terrible. Okay, it's not right. So what? This idea doesn't work? Let's see. Promise constructor, right? So I promise this and this. Set timeout. Resolve. How about what if I just want to? You know what? I have another idea. Or maybe I think this is also a syntax error. Reject becomes. Hold on. Let's try this. Nope. Resolve success. Reject. Hold on. The third one, right? 1, 2, 3. Shall be rejected because the timeout is 200. Okay, let's go to the third one. The third one. Which is the third one? Function yield. I think that's the third one. Okay, this is the third one, right? This one's fault. This one's failed. Yep. Okay, so this one yield, right? So cancel function, that's fine. That's how I want to do it. Cancel. And then rest is going to be this promise. No, rest of value is going to be the promise. Oh, so coming in. We can try to see. I shouldn't print this, right? Undefined success. Yeah, that's not right. Ain't right. You know what? The first one is undefined. Maybe you're doing it wrong. Maybe you should just call it first. Don't get it. But you have to, right? You have to get the initial one. But why would this val is undefined? Because cancel promise get out first, right? Because cancel at 100. So you're resolving this, right? You're trying to resolve this. But why you print this twice? Yeah, why you print it twice? Oh, twice because of this. That's a return. Use new promise. So this promise is side timeout. It doesn't really matter. This one doesn't really matter. Just wait 200. This should be wait 100. So the cancel function, wait 100, it calls. Right? So we have a cancel promise. This is a promise. So they're trying to resolve it, but it's not resolved because it's not called. So this is not waiting, right? This is not waiting. I need this to wait. I need this to reject when cancel is called. How do we do that? When cancel is called, can I call reject inside here? How? I want to call reject inside here. Like I want to say cancel is a function where I call reject. And then when this reject is called, this promise gets rejected. Cancel calls. The call of cancel make this reject call. So if I can get this out like this, reject fun. Reject fun equal to reject. Then when this gets called, I simply call reject fun. Cancelled. What do you think about this? What do you think about this? Oh, this one looks promising. Ah, shoot. Okay, so which one? The last one. The last one. Last one is complicated. The one before the last. Ugh, it's complicated too. But that's fine. Let's try this. I feel like we're getting closer and closer. I just try the last one. That's fine. Yeah, that's fine. No, I don't want to try the last one. Now let's try this. Okay. Okay. So this result is 0. Cancelled at 150. The first two yielded promise resolve and cause result to increment. However, at the T150, the generator is cancelled. The error sensor is caught and the result is returned. But I say rejected. But anyway, I think this one is correct, maybe. So when we call this got rejected, right? So this got rejected. So try with a catch, we have an error. Which means if I log this error, I shall see cancelled. Yes, I saw cancelled. And then generator throw. Okay, generator dot throw. So we throw this, the generator, which will go here, will return the result, right? It will return the result, which means maybe I should do res equal to generator res. Does it hold on, generator throw. What does it return? It will return. Okay, so yeah, it will return. So the generator throw will return something. Now I capture it, and then I go again. So what if I do it this way? Nice. Okay. Getting closer and closer. Okay, let's try everything. Oh, I think I got it. Holy crap. All right, let's just do one more time. So this is to handle create the cancel function, which when the cancel function is called, the cancel promise gets rejected. Okay, so this is handle the generator. Okay, we'll get the value. We'll get the next one. Catch. Get the result. Okay, let's try this. Ugh. Error. Still not good. not good enough. So this one, this is already maybe I don't know. Maybe we do it inside. Nice. Oh, wow. Lots and lots of effort. All right, yeah, that's all I want to do on this one. I think I have to read the previous and then compare our solutions. All right, that will be it for today. I'll see you guys tomorrow. Adios.